Okay, today is 7.1, day 1, and we are also reviewing for a test tomorrow, but I'm going to put that in a separate video. This video is just about the new stuff in Chapter 7. Horizontal and vertical asymptotes and holes. All right, so the first thing I want to do is show you one that I think you can remember and relate to, and it is y equals 1 over x. Just for a moment, try to rack your brain on what does that thing look like again? Anybody draw it in the air with their finger? All right, a lot of people had 2 parts to it. Some people only had 1. That is the first part, but then, yes, nice. It's like that. Okay, good. Now, specifically, it goes through a couple important points. It goes through the point 1, 1, because think about it. If I put in a 1, I would get 1. And it also goes through -1, -1. And then it gets closer and closer and closer like this to the asymptotes, which would be running, let me just do those as pink for horizontal. And the green one has the vertical asymptote. I missed that one a little bit. I'll move it over. There, good enough. Oh, I kind of moved the whole graph by accident. I should probably just move the asymptote here. There we go. Move it. Come on now. There. Okay, so what if I did this to it? Now this is important. This is underneath and still in the fraction. Where would the whole thing move? Say it if you know it. Right 4. Okay, good. As I move this thing to the right 4, what also has to move with it? Asymptote. Notice that moved the asymptote. So that moved which asymptote? The vertical one. Can you tell by seeing that this right here makes your vertical asymptote? The vertical asymptote is whatever makes the bottom 0. In this case, 4 would make the bottom 0. Next is horizontal asymptotes. Horizontal asymptotes, I can't just say, oh, the horizontal asymptote comes from the number on the top or something like that. It's not quite that easy. It is, except that there's 3 possible cases. For the horizontal asymptote, it's whatever on the outside of the fraction. In this case, is there anything that's being added like this, which would have moved the fraction up 8? No, there's nothing out there. And therefore, what is out there? 0. And therefore, the horizontal asymptote is whatever's on the outside. But that only works in the case where the bigger degree is on the bottom. Do you remember 3 cases? Bigger on bottom, bigger on top, same on both. Remember that from last year? All right. Those are the 3 things that could happen. In this case, this one's bigger on the bottom because it's degree 1 on the bottom and it's degree 0 on the top. It's like there's a little x to the 0 there. All right, so this one's bigger on the bottom, and therefore the rule for bobs, bigger on bottoms, is that it's on the outside. Whatever's on the outside makes the asymptote. Now I want to stretch your brain just a little bit here. What if I had y equals whatever's on the outside, right? What if the asymptote is 2x? What would that mean? It would mean the line y equals 2x. As opposed to what we said our last one was there was nothing out here. So we said, well, that's like 0. And that's like saying y equals 0. So what if there's a 9x minus 1 in there? That would mean that there's an asymptote at y equals 9x minus 1. How can you have that? It's called a slant asymptote. That would mean the asymptote for this thing would run like that. I will take a dotted line to show you, because again, it's an asymptote. That would be a horizontal one, so that instead of our asymptote where it is right now on the x-axis, it would be slanted like that. There is such a thing as a slant asymptote. All right. But I don't think you're quite ready to totally understand that yet. For right now, I got to run you through the 3 possible cases. I'm I'm going to write 3 problems down. I want you to write them down with me. X squared over x to the third plus 1. Is this bigger on bottom, bigger on top, or same on both? Bigger on the bottom. And it's not because of that plus 1. It's because the degree is bigger. That's Bob. What did I just say a second ago the rule for Bob was? It's y equals whatever's on the outside. Whatever's outside the fraction. There is nothing outside the fraction. This is supposed to be over the whole thing. If there had been a plus 3, then do you get this whole function would have moved up 3, and therefore its asymptote would have moved up 3? Okay, so that's why we need to say it's whatever's on the outside. Okay, what's usually on the outside? 0. It's true. So this is usually y equals 0. But it's not always. They're in pre-calc now, in honors pre-calc especially. We don't even handle slant asymptotes in regular pre-calc. So, all right. Y is the outside. That's for a Bob. How about this next one? Is that a Bob? What is it? It's a bot. Bigger on top. Now, I know you wouldn't necessarily know this, but this kind doesn't have any asymptotes. So I like to say they're no bots. Like robots? There's no asymptotes for that. That does not mean y equals 0. That means none. There is no asymptotes. You should take notes on this. I think some people are drifting. Don't make me call you out individually. Write on your iPad so that I can tell you're writing these notes down. Okay, and then the last one is, this is going to have to be a same on both. That's the only other option. It's either bigger on bottom, bigger on top, or same on both. I'll give you an example of a same on both that a lot of people don't think is. That's the same on both. Do you get why it would be? If you multiply it out, they both have degree 2. So, bigger on bottom, bigger on top, or same on both. The same on both are the ones that will make you sob because they're so hard. Get what I'm doing there? And they are y equals a ratio of the lead coefficients. Now, it's not that hard, really. What's the lead coefficient on the top? 1. What's the lead coefficient on the bottom? 1. So it's y equals 1 over 1. So it'd be y equals 1. Is it always y equals 1? No. What if I had a 7 here? Then it'd be y equals 7. What if there was an 8 here? Now it'd be y equals 7/8. The idea? Those are the horizontals. This whole thing is the horizontals. Now this can be confusing when I say, here's some asymptotes. X equals 4 and y equals 3. And you're like, well, which ones are the horizontals and which ones are the verticals, though? Well, I'm going to give you a way to remember it, because it is a classic thing to forget. Especially bad if you've got these two answers and you don't know which blank to write them in. We say we got the horizontal blank here and we got the vertical blank here. And you're like, oh, I don't know which one should go where. Try to remember these dumb little words. Vertical and horizontal. You see what I'm doing there? Because now when you see a y thing, you know it's a horizontal. When you see an x thing, you know it's a vertical thing. Horizontal. Got to say it with a little bit of Swedish inflection then. And the x equals is the vertical thing. That must be the vertical one. Okay. So now, I'm going to give you one. My favorite saying comes into play. Can factor, you should. Go ahead and do it. Factor this puppy, and then see if you've learned enough to tell me the vertical asymptote, the horizontal asymptote, and if you're really good, you'll know where this thing has a hole. I'll pause while you give that a try. Okay, so for the factoring part, just to make sure you did that right, you should add x plus 1 and an x plus 2, and it was all over x plus 1 and x minus 1. And then this was special, because those cancel each other out and make a hole. The hole would be at x equals negative 1. Notice we don't say x plus 1. That would be a factor. We wanted to know the root, or the x value of the hole. Do you remember who we asked about the horizontal asymptotes? Bob. Is this a bigger on bottom, bigger on top, or same on both? It's the same on both, and therefore it's the kind that make you sob because you have to think about how to do them, and it's, let me think, 1 over 1, so it's y equals 1. Or 1 over 1, which is 1. Raise your hand if you had that one right. Good. And then the verticals. The verticals are the zerticals, so it must be an x equals thing. And they're whatever would crash your function but wasn't a hole. So I cannot list this as a hole. It's not a hole, it's an asymptote. They look totally different. Asymptotes are dotted lines. A hole is an empty spot in the graph, totally different. So we don't use that hole. We use whatever wasn't a hole, so that one. So then it's x equals what? 1. Now, if I were to make a sketch of this graph, I want you to make a sketch of the graph, put in the horizontal and the vertical asymptote, and don't try to put in the hole because you don't know where it is yet. Yes, sir?
What about the negative 2?
Good question. That makes the function equal 0, but that is not a root. It is not an asymptote, and it really doesn't help that much. It's just one of those, I'm glad you asked, because a lot of kids do that. They say, oh, x equals negative 2 is a big thing. No, it's not. If x equals negative 2, then the function equals 0, but it doesn't crash. It's not a hole. It's not an asymptote. Things that make the top 0 are zeros. They're the x-intercepts. All right, so bottom line is, if we found that, which was negative 2, that means that it hits right there. That's one of your points on the graph. But for right now, just get the asymptotes in there. Okay, did you get an asymptote at x equals 1? Did you get an asymptote at y equals 1? Next, did you have a hole? Well, you can't put that in yet. Where exactly is the hole? Well, you could put it at negative 1. I can't put it in the whole function because as soon as I put it in, it would crash it. But if I cancel that off, I can put the negative 1 into the resulting function. And then I'd have negative 1. Negative 1 plus 2 is 1 over 1 minus 1 is negative 2. 1 over negative 2 is negative 1/2. This hole is at negative 1 comma negative 1/2. And that means it's down here. There's a hole, an empty spot, an absence of point. So where's the rest of the line? I happen to know it goes like this. Now, how could I know that? Because I know that asymptotes are kind of like black holes. They drag you into them. You get closer and closer and closer. Except in this world, you'll never actually go into the black hole. Never go into the asymptote. So I believe real black holes suck things into them, like stars, and light can't escape from them. And there's all kinds of theory. Of course, nobody's been to a black hole, but there's all kinds of theories about black holes that even time would be totally messed up in a black hole. This. So now we have a point. That's just one of many points. What if you're asked to graph something and you've never graphed one like it before? I've given you a tool that you can use to graph anything, but it's not your calculator. An XY chart. An XY chart can graph anything. So if I don't know where this is, it could be here, it could be there. I don't know where it is. So I'm going to graph it with an XY chart. X, Y, and then I'm going to put in a few points and see what happens. If I stick in 0 into my function, I'm going to put in a 0 here and see what happens. I get 2 over -1, which is -2. So 0 gives me -2. That's there. That actually kind of works. All right, how about, what if I put in 1? Any predictions on what will happen? Crashes, because there's an asymptote there. So I'm going to put a line like that. Nothing happens at 1. Asymptote. What if I put in a 2? This will be important, because that'll tell me whether or not I'm in this little realm or if I'm in this little realm. You know, like going like this or going like that. So I'm sticking in 2. I want you to put in 2 into this function. Okay, so I put a 2 here and a 2 here, and I get 4 over 1, which is 4. Did you get 2 comma 4? Okay, then if you graph that, over 2 up 4, you're in this little realm right there. And now I know the rest of the story, because like gravity, it's going to get sucked in both directions. There we go. There's my graph, the red and the blue. Notice there's a hole in my graph. Why was there a hole? Because at -1 here, when you put it in the function, it would make a 0 on the bottom, and that can't exist. Yes, sir. How I found the hole was, first of all, I knew there was a hole here because these things canceled, and that made x equals -1. That part I knew. And then how do I do the other part? I take the -1 and stick it in the equation. Not this part of the equation, because that just disappears. In this part of the equation, I stuck in -1. Once I stuck in -1 here and here, I got a total of +1 over -2, which makes -1/2. All right, that got a little intense, I know. Remember, not on the test tomorrow. This stuff's for the beginning of the next chapter. Now let's actually do one of the homework problems together. I think that'll help you feel the best about it. So let's get to the very first one. It looks like this, kind of the pinky fuchsia page here. Number 1, if you can factor it, you should. Go ahead and factor that sucker. And then you'll see right away that 2 is probably important. Hopefully you'll be able to tell if it's an asymptote or what it is. There's my new function after it's factored. Okay, so some thoughts. Verticals come from the bottom, and horizontals, you can't just say comes from the top. Horizontals comes from Bob. Is this bigger on bottom, bigger on top, or same on both? Same on both. It's same degree. And therefore, if it's a sob, you use, this was the horizontals. Y equals, same on both. So ratio of lead coefficients, 1 over 3. That's your horizontal asymptote. And identify any holes. Yeah, there's definitely a hole. There's a hole. Oh, no, there isn't. If there had been a 2 like this, x minus 2 on top, then there would have been a hole, but there isn't a hole in this case, because there's nothing canceling on the top and the bottom. So none. The verticals, or the zerticals, those come from the bottom here. X equals 2. The domain of f. Domain is what can you feed it? You can feed it everything except what? What's the one thing that will make this thing sick? 2. So all reals, except x cannot be 2. Could have done that with a number line, set builder, all those options. And then it says graph it and describe the behavior near the asymptotes. Okay, so notice it doesn't say you have to use your head. You could graph it with a calculator, but let me just show you how fast it is to graph it with your brain. Okay, y equals 1/3 is a line that runs less than 1, right? And here's x equals 2. It's off a smidge just because my alignment's off on the board. I apologize. But that's supposed to be a little bit to the left. There we go. I got it. And now, where is this graph? Well, I can just check one point that's to the left, like here or here, and find out which it's in, and one point to the right. So I'm going to stick in -1 and see what happens. And I get -1 over -3 minus 6 is -9. -1 over -9 makes +1/9. So -1 comma +1/9. -1 +1/9. All right. There. And that tells me it's going like this. Now, you could have typed it in a calculator. It would have also told you that it was going like that. Then I'm going to take something over here, like where x equals, like, let's say 3. I stick in a 3 and a 3. It's 3 over 9 minus 6, which would be 3 over 3, which equals 1. 3 comma 1 over 3, up 1. It's right there. That tells me it goes like this. There. Was there a hole in this graph? No. Let's say that there was. Let's say that there was a hole at x equals -2. Then I would have gone where x is -2 and put an empty spot right there, because the graph wouldn't have been able to exist there. This did not have a hole, though. I'm just saying what if. All right, that's the new stuff for today. And that's all I have for the video. Oh, wait, I should probably tell you which ones to do. You may do 1 and 3. You may skip number 5. Then I want you to do the 3 on the next page, 7, 8, and 9. These are all pretty straightforward, a little bit of factoring in each one. Although there's one that looks like it could factor, but it can't really. And if it can't factor, then don't. All right, then that's your assignment, just up to there. Don't go further because I don't feel like you're ready. This was meant a shortened lesson because we're also going to review today for the test. So that's all I got for the video for today.